you very much. Hope you had a good lunch and you're ready to hear about some things that I've learned in my career that I want to share with you. But first, I want to thank Matilda and the committee for inviting me to speak. This is my first time here, first time to Malaysia. My wife came with me. We came a little early, and I really enjoyed being here, seeing the city, seeing part of your country. We're just having a great time. So I really am honored to be here and to speak and share. But I'm also very impressed with the work you've done in getting software testing recognized and software quality issues recognized and working with your government in the procurement process to solve that problem. I don't know of any other country that is that far along as you guys are right now. I don't know of any. Now, I've not been to a lot, but I don't know of anybody who has it in the policy like we heard today. That is truly amazing. And I hope to use it as an example in my country to show people what we can do, and I'll talk a little bit about that later. But what I want to share is really my career and learnings I've had throughout my career from the mid-early 70s, yeah, I'm that old, and methodologies we used then, all the way up to today with data analytics and artificial intelligence. But, so I don't seem to have the animation here. There is no animation in here, but we can go without it if we have a problem. So I'll go ahead and start with this. When I started into college, I had no idea what I was interested in. None. So I took basically every introductory course there was. In the US, that's courses 101. I think I looked on some of your university websites and I saw 1001 as maybe introductory. But I took every single 101 and didn't like any of them until I hit computer science. And I absolutely fell in love with computer science, and so much so that I immediately tried to find a job, and I did, and I got to operate that computer, which is obviously very old. It's a 360 Model 40, early 70 vintage. Yes, I hung tapes and I read cards, as John was talking about earlier today, into the thing. But what I noticed is I was an, at best, average student in high school. But when I found something I liked and was passionate about, my first piece of software was a piece of software that wrote in big block letters my girlfriend's name. That was it. Okay? That was the thing I wrote. I was so proud of that, I was so excited. But one thing I noticed is every single one of my classes went up at least one grade level. So from being average to being way above average, just because of being passionate about what I'm learning. It affected everything I did. So my first key learning was pursuing a passion will improve just about everything you do. So that was my first learning. It's my first programming job. So I was a trained software person, writing software. I got hired by a company, Modcom. Modular Computer Systems is what that stands for. They built mini computers back in the day. They competed with people like DEC and some others like that. But I was hired as an experiment, and here's why. I was hired to write what are called diagnostics. How many know what a diagnostic is? A diagnostic is a piece of software that tests hardware. Now, by the way, I did not know this was a test job. I thought I viewed it as a programming job. I knew nothing about testing. And by the way, I knew nothing about hardware. So that's what the experiment part. My school, at the time, I was in the second computer science graduating class from my school in Boca Raton, Florida, in the US. And it was in the School of Business. So back in those days, computer science was either in mathematics or it was in business. At the time, I hated mathematics, no longer true. And so I took the one in the School of Business, and that's where I ended up. But the experiment was, here's the problem Modcom was having. They were having engineers hardware engineers write diagnostics, and the problem they were having is that hardware engineers were assuming it will never fail that way, so I don't need to test it. And as we've heard at least once today, we can't assume as testers, right? We can't assume anything. And so that was a problem they were having. So they hired me, who knew nothing about hardware, and to be honest, I knew nothing about testing at the time. And it turns out I was able to write diagnostics because I looked up, we didn't have the web back then, right? So I had to go to a library and find books on computer science and find out what testing was about, and there was hardly anything written on testing, okay, back then. And what I found was some ways of testing to find errors in hardware on some papers. So I implemented those in my diagnostic, and sure enough, I found some problems right away that got me a lot of attention. And I'm sorry that the animation isn't going to work on this, well, maybe it worked on the next slide. But what I learned was that people react differently to writing up a bug report or a defect. So I was very happy I found a bug. I'm the tester. I was very happy. Now, it turns out the hardware person I wrote the defect against was not very happy. And the manager involved was even less happy. Okay? So, but I learned an interesting lesson here. How we open defects and advertising is very important. So there's one of these first defects that I opened turned out not to be the hardware. It was actually the manufacturing process. One of the machines that did what's called back then wire wrapping was out of calibration, and it was scraping the wires and causing a short. Okay? So, next problem I encountered. I wrote a defect, and I didn't learn my lesson, and I made a big stink about this problem against a piece of software that was running the operating system. And it turned out the problem was in my diagnostic. After advertising around that the problem was in the OS, okay? So I learned very hard right away, you want to treat defects very carefully. Collaborate with them, assume it's your fault first, and then try to work to a solution. So that was one of my key early learnings. Sorry for the busyness of the chart. I was supposed to fill it out, but it's not going to work that way. So I worked for ModComp. ModComp won a computer with NASA to provide the computers that were used on the ground at Cape Kennedy, where the thing was launched, Cape Canaveral. And the computers from ModComp were inside those blue racks. So my dream job, because I grew up in Florida watching the space program, wanting to my whole career to work in the space program, and I got to be the on-site consultant for our company, working with NASA and at the time IBM, who was writing all the software for all of this. And I was learning a lot. I was learning something called structured programming. By the way, that is before object-oriented. And it was being taught, so I learned that methodology, learned how to do the proofs that go along with that. And ended up writing some software. Today we refer to it as firmware, but back then it was called microcode. I wrote simulators, and back then there were no version control or unit test tools. There were no tools. There were only compilers. And that's about it, okay? So we wrote our own tools at that time, including test automation tools. And you'll see a reference here to Glenn Myers, The Art of Software Testing. At the time, I did not know. This was about, that picture was probably taken in about 1979, 1980. So that book had been written, but none of us at NASA knew about it, and NASA or IBM knew about that book. So we knew nothing about software testing. By the way, that book is still a very good book. I think he's up to his 3rd edition of that book. Glenn is still alive. So this was my best technical job ever. Many of the lessons we learned, many of the tools we wrote back then, the processes we developed, still apply today and can be used today. So I just loved the job. Now, while I was a consultant, before I got to do all these cool things on the left-hand side of that chart, I was sitting in an office basically representing ModCon. And neither NASA or IBM really wanted to talk to me much. They wanted to figure everything out themselves. And so I was working at best 8:39 to 3 o'clock. I mean, I wasn't even working a full day. And to be honest, I was getting pretty lazy. And one day in the evening, about the time I was getting ready to leave to go play a volleyball game, somebody walked in, IBM, walked in with a question, and I basically brushed them off and said, well, we'll get to it later. On my way home, I really felt bad about that. So the next day, I went and found the guy, I apologized. I asked him what the problem was. He took me to another person who explained the problem. One of the compilers we had provided to the team to do their job was taking 45 minutes to do a compile. Now, back then things were slower, it took a while, but 45 minutes was way too long. By the way, it was only a piece of code that generated 1K of binary. It was not big, okay? So, 45 minutes. So I did some investigation, and I found out that what we had done is we had created a macro interpreter, which by definition is very slow. And because of the size, the bit structure of the microcode that we were compiling, it just took a very long time. So basically, all I did was take that and rewrote it in pure assembler, and I got it down to 45 seconds. Now, everybody in the world was happy with me, right? The lesson I learned, I refer to that as the first career epiphany. Epiphany is a big event, or a big learning. This is my first epiphany in my career. And what I learned is, if I work the toughest problems my management team has, I'll never have to worry about a job or work. And that has been proved to be true in my whole career. So 45 years of trying to live that out has made a big difference in my career. So I was growing technically, and I changed companies. I ended up getting now my dream job working for IBM. Because they were there, and long story I won't go into, but I ended up working for IBM, getting to do all that cool stuff. And as that work started to wind down, I moved on and went into the, as everybody's, I guess, supposed to do, is go into management. And I went into management, into what we called back then first line or line management, where I managed people, did evaluation, gave raises, but I still was able to be involved technically. And I really, really, really enjoyed that. Then a couple years later, after managing 3 different groups, I had a software group for a while, I had a test group for a while, and I had a hardware group for a while. I went into middle management and became a middle manager. And what that means is you manage managers and you manage the business. You're quite a ways from the real technical work. And I learned that those 2 levels of management are very different skill sets, and that you've got to act differently with your people and your manager's people. And so my second career epiphany was, I much prefer the technical role. Now, it's almost I would use the word hate, but I won't go quite that far. I didn't like the role that much. And I much preferred being a technical person, which, by the way, so that was about the mid-90s when I made that change. I've been on the technical side. I've been a technical leader, but I don't have to do the management HR stuff. Now, I'll do a caveat here. If you're young in your career and you're considering management, I highly recommend trying. You'll learn a lot, but we also need good technical managers in our business. So if you're one of those, stay in it, okay? If you find out you're a good manager, we need them in our industry, especially in testing. Okay, so I went back into technical. I went into my boss's, so he's a VP level. I went into him because I was a middle manager. And I said, you know, and he and I had been talking about me stepping out and going back technical. So I asked him, I said, Brian, what is the toughest job you have that you need to fill right now? Remember, my first epiphany was, what's your tough job? He said, I really need somebody to manage, to lead the technical test team on a very large software release that's going to support GPS. That's the GPS satellite right there. The picture up there, the constellation with all the satellites going around it, there's about, I don't know what the number is right now, it's not a classified number, it's probably in the 28 to 30 satellites for GPS, that's the US version anyway, GPS. That's the control station on the left. It is run by the Air Force, still run by the Air Force today. When I was doing this release, I think there were 2 satellites in the sky. Okay. The GPS receiver was, let's see, 18 inches by 10 inches, and you had to wear a battery pack to power. That's what it was, GPS was like back in those days. Okay. And we were still learning. So I took on this role. We had a very major release with a whole new set of capability to fine-tune the solution that GPS provides. They launched a 3rd satellite so you could get the triangulation. And we ended up in this big test event where we had to sell off a huge number of system-level requirements, and below that was like 1,700 system-level requirements, 10,000. Yesterday, one of the days I heard a paper on SRS acronym was used, a software requirements spec. So we had over 10,000 requirements at that level, and we had to sell those off to the customer, which in this case was the Air Force. So we organized these tests around the way these operators up there run the system. There was like 14 different daily, weekly, monthly scenarios that these guys go through to run the GPS system. From commanding it to check its time, to commanding it to charge its batteries, things like that. Some of those are weekly, some of those are daily, some of those are monthly. So we organized our tests around those operation scenarios. Very good system level coverage. Turns out, by the time we got through all of the debugging, getting everything to work, we ran this very successful test event. The conference room we had our test readiness review in had probably this many people from all over the world that were interested in GPS, that were invited by the Air Force. We ended up going 30 days of testing, and it was very successful. We sold off most of those requirements. However, when the system went into parallel operations out in the facility in Colorado Springs, it went into parallel. So the main system was still running, but we were running in parallel in a backup system, and it failed almost immediately with the live assets feeding data to it. And I had no clue. How could we be so successful, everybody was really happy, and then go out and fail? And I didn't understand it until I went to an event in 1990, so that was about 1995, by the way. In 1998, I got to attend Star West. Anybody heard of Star West? Those are test events held in the U.S. The West means on the West Coast. Star East is on the East Coast of the U.S. I got to go to one day of one event, and I heard those 2 men speak, Rick Craig and Ed Kipp. And it fundamentally changed my view of the world and resulted in my 3rd epiphany, which is software testing is real science. And to coin a phrase I think Eric used, it's engineering. And I absolutely agree, especially when you start rolling in hardware, which if you're using any kind of platforms nowadays, you've got hardware involved, you've got hardware issues involved in that. And I was finally able to explain how defects got through on the GPS system 3 years earlier. And that was because, remember I told you we did those scenarios that the operators did? Well, that's system level testing. And we tested like it was supposed to work. Okay, that's all we test. So if you think about another layer down, what about functional testing? Well, we really didn't do good functional testing. So we had very thin testing across that system. We didn't do boundary value analysis. We didn't do any output forcing. We didn't do any of those kind of methodologies that you learn about in ISTQB. We didn't even know what those words were at the time. So in my 3rd epiphany, I learned software testing is some real hard stuff if you do it right. So at this point in my career, I decided to leave the company I was working for at the time, the big aerospace company. I refer to that time now as my sabbatical. So for 3.5 years, I went to work for actually one of the two guys that heard speak. Ed Kitt. I went to work for his company, Software Development Technologies, and I would teach software testing, teach test automation, and assess companies and projects on how they're doing relative to software testing. And as some of the group of people that were here yesterday for a little roundtable sessions, when you assess testing, and many of the times that we got brought in to do assessment, that a management team would tell us, our test team is broken, you fix it. Generally what we found, it wasn't test that was the problem. It was either requirements or the design phase. It was generally something else. Sometimes it was the test team not having all the skills they need. And so I spent a lot of time for those 3.5 years doing those kinds of activities. One of the last major customers that we worked with at SAT was my previous employer, okay, which was the big aerospace company. And the program manager who got asked to go into this program, the program was in trouble. In the US, contracts are awarded in many different ways, but one of the ways is a cost plus award fee. Now don't think award as a reward. Award is basically profit. So if you do everything right, and you get a 0% award fee because they don't like something, then you get no profit. They'll cover your costs, but you get no profit. And you negotiate all this stuff up front. So we were on an award fee contract, they were on an award fee contract, and the customer gave them a 0. Okay? You don't hear that very often. And so the new program manager that got put in there, he knew me, he knew what I was doing. He called me up and said, I'm bringing in 3 experts, one for system engineering, one for software, one for test. Would you come in and help us? So we negotiated the contract, we went in for a couple of years, and we helped improve their process by putting in good requirements analysis, good unit testing, good integration testing, and good testing skills. And after all of that was corrected, we put in some automation. And because of that experience, a couple of their upper level managers approached me and said, would I consider coming back? And I said, yes, if you will let me work to improve how we do testing inside the company. And it was IBM, but IBM, that part of IBM got sold back in the late 90s, and so I ended up getting merged into this aerospace company. I did join them, and over the next X years, it was about 20 or so, I became a senior technical fellow in the company. By the way, I only have a bachelor's degree, and I was the first senior fellow for testing that they'd ever had. The company was about 110,000 people at the time, and there were 99 senior fellows across the company. And so at least the company started to recognize, yeah, testing is something we need to think about differently. And went on a mission over the next X years to do that. But one of the other things I wanted to do, which is why I'm so impressed with the work that's being done here in Malaysia, is work with our US government to make sure they understand they need to acquire software and software testing differently than they've been doing. Now, over the years, there's a lot of things on this chart. 2006, the government did a study, and by the way, these are available on PDF, if anybody's interested to see them. Some of your documents, to be honest, look better than some of these, but at least that first one on the left is a very good description of testing in an industrial, military complex kind of environment. It's a very good read, actually. Several things that led to the only words I'm aware of in all of the US government acquisition policy that talk about software or testing is that red sentence right there. The new director of developmental testing is responsible for the integration and test of software. And there are a couple of us that worked very hard behind the scenes to get that in there and get it signed by the president so it became law. Okay, that's about it, which is nowhere near what Malaysia is doing with MTSP, to get the acronym right. what you guys are doing. You've got a lot farther than that, and I commend that work. But there's been some good movement, especially down here in 2012. You see the term Chief Developmental Tester. So in the U.S. government acquisition now, for programs that are a certain size, which is pretty big, they're required to have on the government side a Chief Developmental Tester, somebody who's responsible for testing from the very earliest days of a program, which means way before award of a program. So all the design that the government does prior to letting an RFP and then awarding a development contract. So they recognize the problem. They're starting to require the same thing on the industry side. So what I learned during that phase is that improvements can be made in just about anything, a company or your government, through collaboration and compromise, but also with perseverance and passion. It took me about 7 years to get that sentence added to the law. Working through the company I worked for, working through a senator's office, working through things like that. And having to learn how to do that and make that happen. Also going on during all this time, as all of us are aware, right? Technology is changing. The internet starts to take off for me at this point. And by the way, one of the things that occurred was when I did my little sabbatical, one of the things I learned during my sabbatical was I listened to some marketing, they were on cassette tapes, if anybody remembers cassette tapes. I listened to some marketing tapes, and the reason was our company was a small company, and not only did I have to teach software testing, I had to market, I had to do all kinds of stuff. The one thing I remember from that tape about marketing is, if you are passionate about what you do, you will continue to learn, read, whatever you can about the field you're in. So I worked very, very hard to keep myself current in technology and what was going on. So I started to read about this thing called the web, and HTML, and new types of screens, and we were getting ready, the government was getting ready to acquire a new ground system for GPS because it was very old technology. And putting on, what I was recommending to them was, let's just wrap our current stuff with HTML and put a web interface on the front of all this hardware and then slowly move the stuff out of the back. And there were a couple of us who felt this way. By the way, they didn't do that, and it took them another 5 years to finally migrate to a distributed architecture. I personally think if they had done that differently, they would have been able to get to the new system much quicker. Software development methods, most of us in the room have probably seen that. You hear a lot of Agile now. Well, I saw it go from structured programming to several other attempts at improving software to Agile to basically hardware is now just dirt cheap and memory is crazy. I mean, it really is inexpensive. But the bottom bullet there to me is important. Has software testing kept pace? Who thinks software testing has kept pace? Raise your hand. Okay, I don't see any of them. We really have not kept pace with all of that at all. So, technology's changing, the methodologies are changing from a modified waterfall. That's a chart I created a couple years ago to explain to some folks in the government and some of the other companies that were involved in our, let's call it consortium, of how to improve a waterfall model and make it more effective in delivering on time. Of course, there's Agile, and now we've got continuous everything, right? Continuous integration, continuous testing, continuous delivery, continuous deployment, continuous monitoring, and of course DevOps, where we're just dumping stuff out as quickly as we can get it there. Just so you know, I am a big fan of Agile, as has been said many times, when it is done the right way. Because I have seen it work. It does produce higher quality software when it's done correctly. And it delivers that high quality software on a much better schedule than what we've done in the past, what our industry's done in the past. So Just don't get me wrong, I'm a big supporter of it. I do think waterfall still works when done the way it was intended. And if you're starting a brand new systems from scratch, I think you can pick any one of those and deploy it. But that won't support DevOps in that kind of environment. That's a different kind of picture. So I will claim that software testing is getting better, but I'll just give you a quick story without mentioning all the names of the program, is I've actually seen the Agile thing working, and software generating builds virtually every day to the point where the test team could not keep up with the delivery process. Okay? That is the first time I'd ever seen that in my environment. Now, I come from an environment where we're building big command and control systems, when you're talking millions of lines of software, okay? And so we've always been in testing, waiting for the next build. This is the first time I've ever seen it. And by the way, that software came with less defects than we'd ever seen before. But I know it really works. And testing was not able to keep up with that. So what about testing approaches? We've actually seen a very similar chart at least once today. I'll call it classic software testing, ISTQB, what Glenn Myers wrote about in his book, The Art of Software Testing, back in the 70s. Exploratory testing, model-based testing, a little bit about that. I've seen model-based testing. Now, I'm talking about, let's call it a more formalized, standardized model-based testing, where you're using UML, where you're using something called SysML, and something I think John worked on, the UTP, the UML testing profile. You've seen those work. What I don't understand exactly is why it's not being adopted more by certain industries, but there's a few industries using it. It does work. It does help develop software that's at a higher quality, and it helps testers identify testers much quicker, tests much quicker. But it does work. And of course, test automation has kind of evolved. Record, playback, scripted, keyword, data-driven, model-based, behavior-driven, and more coming. Tomorrow I talk a lot about that in my session on the automation front. But the bottom line is there's a slower rate of change in testing, and the evolution, those changes, are not pervasively being used around. So I don't know how it's happening in Malaysia, but I know in the US, when we do these assessments, the testing skill set is pretty low. The use of tools is still pretty low. I think I agree with all the data you showed in your talk, John. It's barely 20% effectively using automation. So what about data analytics, which is the theme of this conference? There's a lot that can be done there, and I will contend that the testing job, by its very nature, is an analytical job. But that was not what was intended for this theme. It's how do we use, I'll use one of my words, how do we use big data, lots of data, in testing? So there's information about what to test and what to retest. Now, if you don't have that data, there are ways to get it, okay? Because it can help you make decisions about what you're going to retest. There's information about test case design and test coverage, and there's ways to get coverage reports. There's information on cyber and performance testing. Automation is now available from a couple of vendors. I don't know of any open source yet, but there's a couple of vendors who have some tools that are starting to help automate the analysis of those top two bullets up there. Okay, I don't work for any of the vendors, but I do meet with them and talk with them and attend their webinars routinely because I'm curious about where they're headed. And so Parasoft has got some tools, which is doing some very interesting things, and Eggplant has some tools that are doing some very interesting things. Now, they use the words AI, and I challenge them on that because I don't think they are. They have some algorithms underneath that you guys suppose you could argue are AI-like. And I talked to them and made some recommendations about what would really help us testers in these kind of tools. And so I talked to them about it, but there are tools coming. if you haven't read this book, Predictive Analytics, I highly recommend it. Okay? It will give you, one is a little scary, especially about this. The power to predict, click, buy, lie, or die. Okay? Because there's some interesting things going on in the community you may or may not be aware of. I was not aware of it. In my preparation for this event, I read that, I did a bunch of research, and I know that this term predictive analytics can help us in tests when the right algorithms and tool sets are available. It is hard to analyze. One of the airplane programs I'm supporting with a big aerospace company right now does multiple test flights a day, hundreds in a month, and each flight gathers a terabyte of data. So how do I analyze that for tomorrow's flight? You can't by yourself. There's some tools that are very impressive that takes all that data and will re-fly the flight, reporting on virtually everything about the system that went on, based on the sensors on the airplane. That's the kind of information we can use. And that tool by itself saved that program millions and millions and millions of dollars just by buying it. Now, it cost about $1.5 million, but over the last 2 years, it's 10 times paid for itself because of the money it saved. Those kind of tools are starting to become available. And as I think several people have alluded to, data analytics will change the testing job. Okay? It'll change the skill sets we need. We need some of those basic things, the old methodologies, John, I think on your chart, to some of those new methodologies. This is a chart I came across in doing my research, which I really like. I'm not going to spend a lot of time on it, but it's an interesting perspective of the analytic problem and where we're headed. This notion of prescriptive, where decision support and automated decisions are being made by software. You notice the yellow stuff up there is human in the loop. And in one case where it says India, this was the company that created this chart, they have a tool which helps make some of those decisions. Okay, but we're headed to an environment where it's all automated. Oops. So, artificial intelligence and testing. One of my biggest problems here is how do we test the AI capability? So you're talking about a non-deterministic system. Any one of our methodologies we teach in ISTQB have to do with deterministic systems. AI and autonomous systems are about non-deterministic. Okay? So we have airplanes or drones or whatever flying around, communicating with each other and making a decision together, not with a human in the loop. How do you test to make sure we don't drop something that blows up in the wrong place? How do we test that? By the way, I do not know the answer to that question. And for those researchers in the room, we need a lot of research here, especially in how to test these systems and assure we don't hurt people with an automated car or an automated anything that's making decisions on its own. So the fact that what's interesting that's happened over the last few years now is there was a lot of talk about big data. Big data fuels AI and machine learning. And the fact that we can process so much stuff in the cloud right now. And let me give you a good story about a test tool that I'm aware of in the US, not well known. Its name is SenGen. So scenario generation is what that stands for. The company's name is Scorpion. Very interesting fellow. I won't go into the story. He has a TV show. Have you ever seen Scorpion, by the way? Okay. It's about him. Walter O'Brien designed this tool. He is a genius. I've met him. I've talked to him about his tool. It claims, and I've seen the output, so I pretty much believe it, by the way. They can test all path coverage you've done any studying in path coverage, it's virtually impossible to do that, because that means you're also using every possible data type through every path of the code, through every decision of the code. Virtually impossible to do. He's getting really close with that tool because he spreads it across the cloud and he uses AI algorithms to traverse the code to make sure he's getting it. Okay? So this stuff is happening, and it's happening quicker every year. I do think it will reduce the number of testers. Now let me clarify that, but I probably should put a parenthetical on it. What I think is going to happen is, I do think exploratory testing and human in the loop is still going to be there for as far as I can see, and I think everybody that's spoken today would agree. But you'll need less testers for the same size program that you do today. But as we heard from some statistics, there's more and more software being developed all the time. The need for our role is going to still be there for a long time. The skill set is going to change. It is evolving. You're going to have to understand some of these algorithms. You're going to have to understand how models are drawn up. There's some of the way that the data is categorized. Much different things than just that function. Because even some of that function from a UML model, we can automate the tests out of the model, the functional tests. Okay? They can all be done in an automated way. That is good. So, my final key learning to share with you guys is to always be a learner. And I've listed some things here. These charts are made available to everybody, right? They can get to them? Okay. These are links. Improving testing through automation and AI. And now, the top two are done by software testing consultants, which is some very interesting data. The bottom one, AI, the new electricity, is a more generic about AI. Really, really good, done by a Stanford University PhD guy that runs that department. And he does it at a level which even I could understand. It's really a good listen about artificial intelligence. So I would highly recommend, and what I really recommend for those in the software testing is that put on your calendar at least once a month, an hour or two, to learn something new that relates to what we do, either in your domain or in the domain of software testing. That's what I started doing, and even though I've retired from full-time work and working a small amount of hours now, I still love the learning. I'm still passionate about what we do in software testing. And I hope that you grasp that and put it into your practice as well. So, my favorite quote, "Per tempo ergo sum," Latin. I test, therefore I am. Okay? I loved it, I've used it. I don't have my lanyard on right now, but when I worked for the big aerospace company, I ran a test conference inside of that company. On the lanyards we passed out, we put that on there. It comes from an article many years ago written by a gentleman named Harry Robinson, who I think today still works for Microsoft, and maybe Google. I don't know where he is exactly right at this moment. His article was entitled "Bumper Stickers for Testers." It is absolutely hilarious. Some cool bumper stickers, and I'll give you my favorite one. Every software tester has the heart of a developer in a jar on their desk. Okay, so that makes sense to me. I'm not sure about everybody else. Okay, but remember that picture of the baby crying? That kind of gets at the point there. So there's a link to his website. Okay. I really appreciate your time, and it looks like I might have gone over. No, I think I have 3 minutes left. So, thank you very much for your attention.